don't, whatever. We're going to take a look today at units and variables. Well, I guess let's do this. We'll call start so I can edit this if I need to. Start. Okay, today is Wednesday, September 6th, 2017. I'm your captain speaking. What we are looking at today are units versus variables. Just took a look at the Unit 1 math tools test where a lot of measurement and like sig figs, just basic stuff that you in theory already knew from last year, were done. In general, they look pretty good, but also there are some tiny little things that need to get cleared up. One of those big things was the difference between units and variables, and it came up in the algebra section that I did last week, or kind of on Sunday. But people were just putting a lot of variables in to units instead of like leaving the units as the units and keeping the variables as what they were. So we're gonna take a little bit of a look at that today. I think next week we're gonna look at some Google Sheets stuff. So we'll have that to look forward to. Anyways, okay. So first thing to recognize is that a unit, it's just like if you're familiar with computer coding at all, it's just like a typecast. We're just calling a number a very specific quantity. Okay? So it's just the type of number. And I know that's like very vague and kind of generalized. Like, what do you mean the type? It could be any type. But, you know, it could be a length, which would be in meters, and that would be the unit type of that. But like length, volumes, masses, those are kind of the categories of units, and then within those we can have our different units as well, such as, you know, for masses, kilograms. I guess if you're running stones as the weird English unit. But it's just the type of number we have. The variable, this is representing the number itself, or what will soon be a number. Okay, so it's actually like the physical number is sitting in this variable spot, and that's an important like distinction to make right there, because the variables are numbers, so to speak, even though they are some weird letter. In the end, they are a number. Whereas a unit, it is not a number. It is just specifying what we have here. And that's something that a lot of people are messing up. For example, like let's just say I have, I'm just going to make this up right here. I've got an equation, something like, I don't know. What would be a good one? Let's just go with G. Why not? Big G. Equals, like even numbers, no decimals makes life easy, right? Let's just go with like 4 cats. And here, let's do our variables in a different kind of color for us. So 4 cats per 5th root of dogs. Okay? It's a weird unit. The unit doesn't make any sense. Doesn't matter. It's just the unit. And then over here, this will be like d to the 5th root. Okay? It's just, so we have g equals 4d to the 5th. It's just an equation. It's just some variables. If these units weren't here, it would just equal g equals 4d to the 5th. That's all it would say. But these units are here, and they're causing us problems. So let's figure them out. Okay. I am going to say, for the purpose of this problem, that G is measured in cats. That is the units of G. And that D is measured in dogs. Maybe it'd be smarter for C to be cats, but we're in GATS today, whatever. Okay? G is measured in cats. D is measured in dogs. These right here, these are the units. That's what we're measuring in. These right here, these are variables. Okay? So the type of the number we have is cats or dogs. Those are the types you could be. The number representation itself is either G or D, a cat or a dog. Okay? Now, if I said something along the lines of what is G if there are 8 dogs? This is where a lot of people are messing this up. If there's 8 dogs sitting here, 8 dogs, units, actual variable, then this equation would look like this. It would look like G equals 4 cats per the 5th root of dogs times, oh man, this is going to be a fun one, times 8 dogs to the 5th. Oops, I meant to make this to the 5th root. What I just did here, I just made that the 5th root because I just recognized that my units are going to be off. Why didn't I recognize that earlier? If you wanted to make something to the 5th root and you didn't want to write it in fractional form like that, here's a big radical for all you radical fans. That's the 5th root. There we go. That's better. Just as a side note, you could write any root as a fractional exponent. You can actually take this one step further and say if I had like a root of a quantity squared or raised to a power, I could just place that to the power over there, and that is the same. Anyways, here's the 5th root of 8 dogs. That's even gonna be weird. Okay. What's going to happen here in terms of what are going to cancel is this unit of the 5th root of dogs is going to cancel with this unit. Okay? That is what is going to cancel. And that's it. That's the only thing that cancels here. Because this unit, the 5th root of dogs, is being canceled with the 5th root, sitting right here, of dogs. Notice how the square root didn't get canceled. The square root is still there. I can't get rid of it. The only way I can get rid of a square root, or a 5th root here, is if I raised all of this to the 5th power. Then I could be like, oh look, the radical goes away. But I'm not doing that. I'm not doing anything weird like that. So the dogs can go away. The 5th root of dogs, the 5th root of dogs. What I'm then left with is G equals 4 cats times the 5th root of 8. Whatever number that is. Kind of think about that. The 5th root of 8 has to be somewhere around like 1 point something, maybe like 1.4, 1.2. I'll leave that for your calculator to figure out because I'm a human. But this is some number here, okay? We canceled out the dogs. Notice we didn't put in a number for cats. Cats is still just a descriptor here. It is just a unit. It is just what is the type of variable we're getting that describes this variable G, some number we're looking for, okay? So I didn't plug in anything for cats. I didn't change anything down here for dogs. And I am just going to have this number here in the end. So that's that setup there for that. A lot of people, and what I saw a ton on the test today, is a lot of people were just deciding, hey, I'm going to put in a number for there. And I like circled that a bunch and put question marks everywhere. And I was like, I don't know what you did. Because you just shouldn't be doing that. So just be aware your units aren't setting up to cancel there. They're setting up, the units are setting up to cancel. The radicals are not, and neither is the number. Okay, and no numbers go into these variables right here. So just something to be aware of as you're doing this. Okay. That is the big takeaway from today. A lot of people did their metric prefixes correct, which was cool. A lot of people with resounding success did the mass to weight conversions correctly. So super stoked about that, but people do that right nearly every year. But super happy once again to see it's true. Looks like we can do that. A lot of the algebra was correct. Like I said, this was the big thing I saw here and kind of a mess up. But interestingly enough, what I personally think is the easiest section of the test had a lot of people mess up on it. On the section in the back where you were asked to give reasonable amounts of quantities. And I still have, to this very year, every year I've done this, I still have people telling me that a frog is 100 kilograms. Like a frog is 200 pounds. And, you know, I'm not Jiraiya, but there's no frog that big. Okay? You know, frog, kilogram, maybe 2 kilograms tops, probably less. A lot of people mess that up. So the section on the back where it was just kind of reading a story and then trying to pick the most logical answer, a lot of people messed that up. Don't understand why. Is what it is. Okay? But nothing too crazy there. I guess since I have a little bit of time here before the AP class gets on, let's look at some Google Sheets real quick. Guess you guys had some